we wanted to talk a little bit about the problem with where AI is right now. Obviously, LLMs are such a huge breakthrough, but they also have a lot of problems. And part of the problems uh, uh, are a result of how good the quality of the text that they produce. Um, so there's a problem with it being able to easily spread false information and mislead people, and even perpetuate biases that are either in the data or biases presented by users to the LLM. So there's this problem of hallucinations, and it's basically where the LM is producing quality appearing content, but this content is false or not fully correct. So we need to figure out how to deal with that with AI. So if we don't, we have issues where where not only can we just output incorrect information, but it can also cost companies a lot of money and even put people in danger. So, for example, there's one case in Air Canada where the AI that they were using hallucinated a refund policy, and then Air Canada was forced to abide by that policy. And then we have a bunch of other examples here where the AI can very easily produce very bad results. And of course, whenever you have a problem like this, when these LLMs are being used in more and more places, the thing that's going to come next is going to be the regulations. But before the regulations, we still have this huge cost, right? So we have brand damage. We have the danger from specific things in highly regulated or highly sensitive fields, like, for example, in healthcare misdiagnoses or legal errors. So with these hallucinations, there's been a couple of things done to try and solve them. Some have tried to solve them by purely through prompt engineering. And maybe that can improve it somewhat, but it still has that risk there. There's another solution here where we're talking about RAG, so that's retrieval augmented generation, and that's where you're giving the LLM some context to try and limit its creativity. But that doesn't always solve it too. It can still hallucinate off of the data given to it, the augmented data given to it through RAG. And really, the quality then just is sort of moved from depending on the LLM to depending on the data that you're providing it. So with Pythia, what we wanted to do is to figure out, how can we make people aware of their quality and give them actionable information that they can use to improve their system. So a big part of what we're doing is extracting these claims. So we want to really get that to understanding the factual elements of the text that's being produced, and that allows us to do a lot of really cool things. So let's just improve accuracy over time and tailor the monitoring to your system. You can look at these. You can look at these claims. You can look at these results instead of having just like a black box metric or some system that only we only know how well it performs on a benchmark. So by doing this monitoring, you get reliability. You get to know how your system's doing over time. This can be done in ways that are cost efficient, so that you're not like spending too much on doing these extra checks. And if you compare this to like the other options that are frequently done nowadays, where you have either some sort of very rudimentary check, which will often be insufficient to actually give you the reliability, or you need to have a large manual labeling operation in order to label for your particular problem, and that's going to be very expensive. Because if you're working in one of these sensitive fields, generally just a random person will not have sufficient skills. You'll have to pay someone with sufficient background in that domain to actually label what you're producing. And another problem with that the human-based labeling task is that's not scalable. It gets really expensive once you start wanting to deal with millions of potential examples. And as I said, like the regulations are coming, and so if you want to be able to be ready for these regulations, you want to have a system that lets you understand what's going on from your LLM. And then what we're doing is that we're not just giving you just a score, we're giving you the ability to have to like run the score, get the claims, run other validators to give you real insights into your system. So let's talk a little bit about the methodology behind Pythia. So first, let's talk about the usage scenarios. We're breaking it down into sort of three types. There's a zero context. This is just open question and answering. So your users are just asking your LLM based system questions and they get responses. No like inherent documents are being no documents are being used to like augment the generation. The next one is this RAG, this retrieval augmented generation. That's where the user gives some sort of input, some sort of question, and that's used to retrieve documents. And then the answer is in some way when the prompt is constrained with those documents. And then the third one is where the input is much more constrained to the context provided. So, for example, an example of this would be like with these three would be with open question answering. It might be something like very general, like, oh, what are some what medications might interact with this prescribed medication for me? So if you ask it to open question answering, it's going to depend purely on what the LLM has learned. With a RAG based system, you'll take that question and search for documents and probably get a bunch of documents related to the different medications. And then the LLM will be asked to answer that question from these lists of documents. And then you have summarization here. And the question in summarization is really kind of optional. So you have like some sort of information, let's say about that prescribed drug, but it's like a lot of text, and maybe the patient can't fully understand all text, maybe it's too technical. So you have it generate a summary, and then if you want, you can guide that summary with a particular question, like, oh, summarize the interactions mentioned in the documentation for that drug. So these scenarios sort of set up what you might want to test, and the testing at a certain like abstract level can be the same, but some of the details of like how you might want to interpret the data will be different. But Pythia supports all three of these examples. So the first step, as I mentioned before, we want to extract these claims. A lot of existing methods, they work on either sentence level or on the entire text or chunks of text. And whereas that can work, that can get good scores on like the benchmarks. It's a black box approach. So you get these results that says, oh, this is good generated text, or this is bad generated text, and you don't really have much to work with from that. And that means that you don't know how it actually works on your problems, whether that system is actually a good measure, and you also don't get a lot of actionable information back. Pythia extracts these triples. So these triples are subject, predicate, object. We see some examples down here. So like patient has diagnosis, type 2 diabetes. So that's in the sentence above, that's the NIDM. So we have the patient sort of implicit in the sentence, and they have a history of, so that's going to give like they have a diagnosis of, and NIDM there is type 2 diabetes. And these claims serve as sort of like a breaking down of what's in the generated text and in the reference text, so that you can compare these actual claims being made. And it gives a very fine-grained analysis of your generated texts. So then once we have these claims out, we want to categorize them. So the categories are going to be dependent on which data set which part of the data they're in. So if it's in the references, but not in the response, that's missing. Usually that's not a problem. It depends. So for example, in summarization, there will necessarily be some missing claims because you are summarizing, so you're not going to necessarily have all the detail of the reference. Um, then we have the ones where they sort of share the fact in common, but they may contradict on what the actual fact is. So, for example, in the drug interaction example I used before, so this would be a case of maybe the document says that a drug is safe, but maybe the LLM hallucinated that there is a negative interaction, in which case we'd mark that with the red X. If it marked it as it did say like, oh, there is no interaction with like this thing, we would mark that with the check mark. That would be an entailment. So entailment means that the claim is shared between the references and the response, and it's supported in the references. A contradiction is where the matter of the fact is referenced in both, but what's claimed in the response is not supported in the references. It's a matter of fact refuted. Neutral is where it's something in the response that's not supported or refuted by the references. So there doesn't appear to be an overlap in it. So the hallucinations will be in the contradictions and the neutrals. Most of the time, the neutrals are maybe less dangerous, but they're also very difficult to check unless you have another external data source. So when we compute our accuracy metric, we basically use a weighted harmonic sum of the rates of entailment, contradiction, and reliability. And actually, you might notice here it's like 1 minus the contradiction rate. So it's really sort of like the weighted harmonic mean of entailment, non-contradiction, and reliability. And this really gives us sort of like an understanding of how good the system's working. But you can also come up with task-specific metrics. So, for example, you can understand by looking at a schema for the triples that are extracted, you can determine what entities and what relationships are relevant to your task or more relevant to your task. And then you can weight those things stronger so that maybe understanding like aliases of the drug is not as important of a thing as understanding interactions for a drug. So you want to weight these assistant interaction relationship much higher than aliases. And then you can also try and see like how well something answers the question. So you can measure a general response against a question with a BERT model, and that really then sort of opens up to you want to have a good variety of validators you can use. So there's ones here. This is an example like detecting prompt injection. You want to have that on your input. Detecting toxic language. So you want to make sure that that your LLM is not saying something that's going to embarrass or harm your brand. And by having these things in there, not only do you have a system that lets you just measure over time, but it can also potentially give you something that you can react to. So if something triggers an improper tone, so let's say you want to make sure it has a financial tone to it. Improper tone, you could perhaps not let that result go out, or perhaps regenerate the result. You can take action before it's caused a problem. And so with all these things that you're checking, you also want to be able to monitor it over time. And that's a big part of like of what Pythia does. It lets you do these checks, lets you do this accuracy measurement, and lets you monitor it over time to make sure that your system's not having some sort of deviation problem. So with that, I think I will hand it over to Aline.